Hello guys, today we're going to be finishing chapter 5. Even though you already did the chapter review for homework, we actually didn't give 5.6. We're going to give 5.6 today. The good thing is that it's an easy subject, so we can get into the flow of doing classwork again. So pretty much 5.6 focuses on finding inverse functions. Now, graphically, there are a couple of ways we can work this. First of all, to determine whether we're looking at an actual function, we do the vertical line test. If it only touches once, then it is a function. In order to find or determine whether the function I'm looking at has an inverse, again, I'm looking at this is a function. In order to determine if this has an inverse, I do what's called the horizontal line test, which is horizontal lines. If it touches more than once, then it does not have an inverse. So this is a function, passes the vertical line test, but it does not have an inverse because it does not pass the horizontal line test. Let's look at another example. Let's look at this cubic function. It passes the vertical line test, so it is a function, and at the same time, it passes the horizontal line test. So it also has an inverse. I don't know what that inverse is, I just know it has an inverse. Profe, do all cubic functions have inverse? Not necessarily. This is a cubic function. It passes the vertical line test, no problem. But what happens when I do the horizontal line test? Does not have an inverse. So again, right now, all I know is determining via graph if a function I'm looking at has an inverse or not. For the people who are kind of sharp or smart, they're already determined, since given my n behavior, no even degree function can have an inverse based on the concepts of n behavior, which you should know. So basically, only odd functions might have inverses, never even functions, due to the way n behavior works. Now, let's look at, via graph, okay. Let's look at this particular case. Let's look at example 1. Writing a formula for the input of a function. So let's say solve y for x. All you have to do is, and they tell me that f of x is 2x plus 3. When they tell you solve y for f of x, all you have to do is change your f of x for y, and now you isolate your x. Minus 3 becomes y minus 3 equals 2x divided by 2 divided by 2. So when you're solving for x, all you have to do is change your f of x for y, and then isolate your x. You send everything over to the y. And you'll see, normally you isolate your y. So, Profe, why now do I have to isolate my x? You'll see in very short time. You'll see like today, in about 2 minutes, why we do this. So that is when they tell you solve y equals f of x. Now, let's say they tell me, now we're looking at actual example 2. They're telling me find the inverse of this linear equation. Find the inverse of a linear equation. Linear equation is a line. It passes both the vertical and also the horizontal line test. So it does have an inverse. And also degree 1, it's an odd function, so no problem. Step 1, And again, I always recommend you do these steps in this order. There are different ways to do these steps, but students sometimes forget the easiest steps. Step 1, change your f of x for y. That's always going to be step 1. Step 2 is the step that most students forget, and it's the easiest. Step 2, all you have to do is switch your y's and your x's. That's all you have to do. Switch your y and your x. X equals 3y minus 1. And now you isolate your y and you're done. You add 1, so it becomes x plus 1 equals 3y. Then you divide by 3. So y equals x plus 1 over 3. That is the inverse of this. And if you can see, here I'm multiplying by 3 and subtracting 1. Here I'm adding 1 and dividing by 3. Pretty much the actual opposite, inverse. Now the way the book does this is they solve for x and then they flip the letters. But what I've noticed is that many students isolate x and then forget to flip the letters. But it's the exact same process. Do it however you want to do it. But I do it this way because I changed this for y, flip your x. That's already very good partial credit. If you don't do anything else, that by itself is decent partial credit because you know that you have to change the letters. And then you just isolate and you're left with your actual answer. Okay? The book does the isolations and they flip at the end. It's the exact same thing. I like flipping in the second step so I don't forget. So that's pretty much finding the inverse of a linear function, which is example 2. Now let's go over example 3. Example 3 is finding the inverse of a quadratic function, but they give you a special rule when x is greater than or equal to 0. Because what happens when x is greater than or equal to 0? I would only have half a parabola, because this is what happens when x is less than 0. Now, if I'm only looking at half a parabola, this half a parabola does have an inverse. So given this special rule, only half of the parabola, you can actually find the inverse. So again, very simple. The exact same steps. Step 1, change your f of x for y. Step 2, flip your y's and your x's. Again, when I say flip, all you have to do is literally just change the letters. The degrees and the numbers before them or after them or under them, they stay the same. All you gotta do is whenever there's a y, you write an x. Wherever there's an x, you write a y. What do I do now? Isolate my y. Square root of this, square root of this. This cancels out, and the inverse is pretty much this. And look, here I'm squaring a variable. The opposite of squaring is square root, and you know the inverse is the square root of that variable. Again, very simple. Change f of x for y, flip your x's and your y's, isolate your y, and you're done. Nothing else needs to be done. Let's go over, that was example 3, let's go over example 4. Isolating a cubic function. Isolating a cubic function. Cube. Step 1 is change your f of x for y. Step 2 is flip your y's and your x's. Step 3 is isolate y, and you're done. Minus 1, x minus 1 equals 2y cubed. Now remember PEMDAS. This is, when you're isolating, it's the opposite. So you do the divisions first, and then you do the exponents. Cube root. This is a third power. You do a cube root. And that is the answer. Y equals cube root of x minus 1 over 2. Okay. And look, here I'm multiplying by 2. I'm adding 1, raising to the third power. Here I'm subtracting 1, dividing by 2. Cube root. Everything's the opposite. That's why it's called the inverse. Let's do example 5. Again, pretty straightforward. The exact same process applies to every single one. F of x is substituted for y. Flip your x's and your y's. Isolate y. Done. Now, example 5 says finding the inverse of a radical function. Step 1, change your f of x for y. Step 2, change your x's and your y's. Step 3, isolate y. Here, you can't touch the radical until you get rid of the 2. The 2 is multiplying, so I divide by 2. So I'm left with x divided by 2 equals square root of y minus 3. Now I square this to cancel out the radical. And I have x minus 2 squared equals y minus 3 plus 3 plus 3, and you're done. So the answer is x divided by 2 squared plus 3 equals y. That's the inverse. Boom, pretty much that's the class. Now there's a way to verify that you're looking at the inverse, but you know, it's in the book. I don't actually ask you to verify if it's an inverse. If you want to know, all you have to do is that's composition. We haven't given composition yet, which is plugging it in. That's why I usually don't give example 6 yet. We'll see it later when we give composition. Right now, that's the class, finding the inverse. Now, one thing, right now, this chapter focuses mostly on arithmetic. And all I'm going to do is evaluate the arithmetic, so the operations, and also just having you look at the graph and determine whether the function has an inverse or not. Now, I'm going to show you how to draw the inverse, but you don't need to draw the inverse for testing purposes. You might need it for SATs or MAP tests, but I'm not going to grade you on this because drawing them is not very simple. It's actually quite confusing. Now, let's say you have, for example, this particular expression. In order to draw the inverse, what you do is you draw a perfectly diagonal line, also known as the line y equals x, perfectly diagonal line. And in order to draw the inverse, you reflect across that line. So, for example, this would be reflected like this. And this would be reflected like that. So the inverse would be the reflection along a perfectly diagonal line. When it's like this, it's very simple, but then they give you, different expressions, and it's not that simple. Por ejemplo, this is the diagonal line. This will be reflected like this, and then here you're going to have something like this, and then here you're going to have something like this. Not that simple. And again, I'm not going to ask you to draw the inverse in the test, but I just want you to have an idea that in order to draw the inverse, you reflect across a perfectly diagonal line, 45 degrees, or also called the line y equals x. Perfect diagonal line. You don't need to draw for the test, just know that's how it happens. And what you do need to know for the test is to recognize, does this have an inverse? Yes, because it passes the horizontal line test. Does this have an inverse? No, because it does not pass the horizontal line test. That's it for the class. Now, for homework, please do 5 through 20. Just do 5 through 20. The first is just like the example 1 pretty much, and the rest is the rest of the class. Actually, no. Give me a second. Let me write down the examples I want you guys to do. I do apologize. That's not true. So please do 5 through 8, 13 through 16, 23 and 24, 35 35 through 42. That is the homework for today. Please upload it before 10 p.m. Any questions, let me know. We'll set up a video call. In the morning, I'm not going to be at home, but I will be available via Teams. If you have any questions, let me know. Glad to be back. Hope you guys are all okay and had a great Semana Santa. Let's do this.